Hi everybody, welcome to our Unit 5 retest review. So first off, this unit is about ionic bonds. And so what is that? It's a bond between a metal, which is a cation, and a non-metal, which is an anion. Electrons are transferred from the metal to the non-metal to make a positive and negative ion. So some properties. Ionic compounds are brittle. They have a high melting point, high boiling point. They dissolve easily in water, and they conduct electricity when dissolved in water. Not when they're by themselves, but just when they're dissolved in water. And when you conduct electricity when dissolved in water, what that is called it's called an electrolyte, just like in Gatorade. So the first thing we learned about in this unit after properties is naming ionic bonds. So whenever you see an ionic bond, you'll always see your cation or your metal first, then you'll see your non-metal or anion second. So that's how we're going to do this. So the first things first, when you look at your equation, you need to say, okay, where is my metal? And so if it is in group 1A, 2A, aluminum, zinc, or silver, then you just write the name of your metal. Super simple. If it's not one of those elements or in one of those groups, you're going to write the name of your metal, and then you're going to find the oxidation number and put it in parentheses, and then the number, instead of it being like 1, 2, or 3, you'll do it in Roman numerals. Second, you're going to move on to your non-metal. Then you're going to ask how many elements are in my anion. How many non-metals do I have? If you have 1, you write the name of your non-metal and you change the ending to IDE. An example of this would be like oxygen would be oxide, nitrogen would be nitride. And then if you have 2 or more, you're going to write the name of the polyatomic ion. Okay, there's a list of polyatomic ions that we gave you earlier in the year when you look at your periodic table. And just so you know, polyatomic means many atom ion. So that's where that name came from. So step 2 over here, step 3 over here is find the oxidation number. So right now we're going to talk about that. So the first thing you want to look at is you're going to look at your compound. And you're going to say, okay, I have metal and non-metal. So the first thing you're going to look at is how many metals do I have? And so in this case, which is nickel blank phosphide, that's what we're trying to figure out, is how many. So in this case, I have 3 of them. Okay, I have 3 of them. Then I need to go and I need to say, okay, my oxidation number. What is that? For this is what I'm looking for. You have to find your oxidation number. So I'm going to look at it. So that's going to be my X. And then I move on and I'm like, okay, so how many of my anions do I have? In this case, I have 2 because phosphorus has a 2 next to it. And then my oxidation number for phosphorus is -3. And this whole thing equals 0 because when you add up all of your stuff for your ion, the total charge should be neutral or should be 0. So then you go through, once you have figured out all your numbers and you put them where you go, you do your math. 3 times x equals 3x. 2 times -3 gives us -6, which so our formula ends up being 3x minus 6 equals 0. I add 6 to both sides. Then I end up with 3x equals 6. I divide that by 3, and I end up with x equals 2. So the oxidation number for nickel is going to be 2. So if you're working on this through Pear Deck and you're like listening to this, or you're working on it through Pear Deck, you can write this on your screen for this problem, or you can work on this problem with me on a separate sheet of notebook paper. So now we're going to talk about naming compounds, and we're going to go through and we're going to use this chart. So the very first thing we do is we look here, and the first thing we look at and we're like, okay, where is this metal? So we have K. Potassium is in group 1A. So all I have to do is go in, and all I'm going to do, I'm going to name my metal. Okay. Then I'm going to go here and I'm going to say, okay, how many elements are in my anion? and I look and I'm like, okay, there's just a P. That's only one. So I'm going to come here and I'm going to say, oh, okay, I'm going to write the name of my metal, and I'm going to write the name of my non-metal. I'm going to change it to IDE. So this is phosphorus. And so I'm going to change this to phosphide. Okay. So now we're going to look at our next one. So our next one is Cu. We have Cu right here. We look and we're like, okay, where is Cu? Cu is a transition metal. It's right in the middle of the periodic table. So it is not in group A, 1A, 2A, and it's obviously not aluminum, zinc, or silver. So the first thing I'm going to do is I'm going to write the name of my metal. And then I need to find out, what is this oxidation number thing about? So then I did all the math for this. So how many do I have? I have two. So how many metals do I have? I have 2 coppers. Then I write my oxidation number. I don't know what that is. So that's my X. Then I look at how many of my anion I have. Okay, then I look at how many of my anions I have. A lot of people would say, oh, I have 3. But one thing is you have to recognize, oh, this is a polyatomic ion. So this 3 is part of the ion. It's not telling me how many I have. So I have 1 SO3. SO3 just happens to be what is that? Sulfite. I only have 1 of them. And then sulfite's oxidation number is -2. So then this is what I got, and the whole thing equals 0. Then I do 2x minus equals, then we have 1 times -2 gives me -2. Then I add 2 to both sides. I end up with 2x equals 2. And then I divide by 2, and I get my oxidation number for copper, which is 1. So I end up with copper 1 sulfite. Okay. So now, if you're working on this through Pear Deck, you can work on it through here, or you can write these down. I'm going to give you a little bit of time. And on Pear Deck, the answers are there. Okay, so now we're going to move on to going from the name to the formula. Okay, so we're going to go from the name to the formula. So first thing we're going to talk about is the crisscross method. So when you're using the crisscross method, the first thing you're going to do is you're going to write I'm sorry, my brain is off. You're going to write your metal and your non-metal with their oxidation numbers. So aluminum has an oxidation number of +3, and then oxygen has an oxidation number of -2. And then what you're going to do is in order to get the subscripts, you are going to switch. You're going to crisscross them. Okay, so this 3, and one thing is you're going to switch the number, not the charge. So we're going to take this 3, and this 3 that was with aluminum is now going to become oxygen's subscript. Okay, then we're going to take this 2, and it's going to become aluminum subscript. But one thing I want you to notice is when I brought the 2 down, I didn't take the negative with me. I did not take the negative with me. I just took the 2. So then the answer to this is Al2O3. All right. And then something else is when you're doing, you must use parentheses if you have more than one polyatomic ion. Be sure to crisscross outside the oxidation numbers and write it outside the parentheses. We're going to see that in just a second. So here we have our 10. So here we have 10,4 sulfate. So up here I have my 10,4, and then I have my sulfate. And so what I did was I switched them. So the 4 is going to go with my sulfide. Sorry, I said sulfate earlier. It's going to go with my sulfur. And then the 2 here, not the negative, just a 2, is going to go with my 10. But one thing that you'll notice is this is 2 and 4. 2 and 4 can be simplified to 1 and 2. So that's what I did here. And so this is going to be our final answer right here. 10 SnS2. So then I have calcium chlorate. Okay, calcium chlorate. So what I'm going to do is I'm going to switch these just like I did last time. So this 2 is going to go over here with the chlorate. Oh man, this is well, too bad. And then this 1 is going to go over here with the Ca. Sorry guys, I just noticed that this is a 3 and this is a 4. I sincerely apologize. There's nothing I can do about it now. And so then, as you can see, I switched them, and then in our final answer, which let me see if it'll show it to you, I dropped the 1 that was right here. So there's no 1. It's just Ca and then chlorate, and then the chlorate. Actually, that's perchlorate, but let's keep it moving. So again, if you're working on this on Pear Deck, here is a bunch of practice problems so you can practice the crisscross method. So now we're moving on to one of our last things that we're talking about, and this is our Lewis dot structures. Okay, so when you have a Lewis dot structure, an ionic Lewis dot structure, you're going to have positive ions and negative ions. And so when you have positive ions, you're going to have no dots, and then you're going to have brackets are going to be optional, and you're going to write your oxidation number. For your negative ion, you're going to have 8 dots for all of your negative ions when you're finished. And then you need brackets, and then the oxidation number is written outside of the brackets. It shouldn't say brackets optional. I don't know why it says that, but okay, so now we're going to look at 2 Lewis dot structures. So this first one is going to be between sodium and chlorine. Sodium is in group 1A, so it has 1 valence electron to start. Then we have chlorine, which has 7 valence electrons, 7A. And so what's going to happen is whenever we're making a compound, we always want to have 8 valence electrons, the octet rule. So what happens is sodium gives its 1 electron away to chlorine. And so then both of them are happy. And if you notice, just like I said last time, I have brackets. They're optional. In this case, we wrote them. And then, but our positive ion has no dots around it at all, which you'll notice. And then our negative ion has 8 dots. In this case, it's dots and X's, but you get it. Okay. Then we have our calcium and our chlorine. Okay, our calcium has 2 electrons to give away. But our chlorines, each of our chlorines have 7 valence electrons. Okay, calcium has 2, chlorines have 7. So in order to get to 8, they only need 1 more. So calcium is going to need 2 chlorines, and it's going to give 1 of each of its electrons to each chlorine. And so we end up with 1 calcium with a positive 2 charge because it lost 2 electrons. And then we have our chlorines with our negative 1 charges. All right, so this is where you're going to write these answers and you're going to work them out. You can do this on a separate sheet of notebook paper, so you can pause the video and work them, or you can go on to Pear Deck and work there. So, last question is, what groups would make this Lewis dot structure? Okay, so when you're solving this, you can do this on Pear Deck, but I'm going to walk you through it. So it says, what groups would make this Lewis dot structure? The easiest way to look at this is to look at the oxidation numbers and then think of what groups make those oxidation numbers. So this has a plus of just a positive oxidation number. If you ever see a plus by itself or a minus by itself, that means it's positive 1. So you think about it, okay, what group has a positive 1 oxidation number? Positive 1 oxidation number is group 1 or group 1A. They're the same thing. Then, so first, group 1. Then we look at negative 2. Okay, and we're like, okay, this is a negative 2 oxidation number. So if you have a negative 2 oxidation number, what group is that? That's group 6A. Okay, so that's going to be our answer. Guys, thank you so much for watching this. I hope you learn a lot. Good luck on your test, and y'all are going to do awesome.